stands for Data Science of the Natural Environment and is in collaboration with Lancaster University and CEH. There are 3 ongoing projects, and one use management was one of it.
It worked. It just took some time.
Yeah, it worked. Yeah, it's one
Yeah.
So this slide shows the work I did on the previous ice sheet problem. So this is trying to recognize the melt region in Greenland using some thresholding and edge detection techniques. And before I joined Lancaster, I did my PhD in Glasgow in environmental statistics. The topic of my PhD was about statistics modeling of space weather. Space weather refers to the electromagnetic disturbances in the near Earth region. And after that, I did a short postdoc. I worked on 2 small projects. They're both about water, energy, food system. And I'm going to talk about the one project called WEF here today, because I think this one could be related to some land scale problems. The title for the talk is called An Indicator for Resilience and Security of the Water Energy Food System in Industrialized Nations. So the motivation why we need a WEF, a composite index for the industrial countries. This is because the WEF system is very complex. It has some interlinked features, such as water can be used for the production of food and energy and food waste are also impact on each other and their potential threats that we're facing. So it's important that we're able to measure the resilience to keep us better informed. And why industrialized nations is because we consider the high accessibility and availability to such resources, and food, energy, water can mask some dynamics effects. So therefore, the solution to this is that we develop a composite indicators based on the currently available index and trying to measure the resilience. So the definition for a secure WEF system is that we can see it as a system in which everybody has access to sufficient water, energy, food resources. And the resilience indicator is regarded as a metric to measure the resistancy of the resources to any potential threat. So this is the structure for the composite index. So we consider 4 different sectors. The first 3 are water, energy, food, and we call it WEF availability index. And also we're considering people's access to these resources. So we name it a 4th sector, which is called the household sector. So these kind of represent people's accessibility to the resources, and then we combine the WEF availability and accessibility as the WEF resilience index. So how we did this was that we started with an online survey that we asked our experts' opinion on first choosing the indicators, current existing indicators for doing this composite indicator, and then we asked them to compare the importance among these existing indicators. So, and then we used a process called AHP, analytical hierarchy process, for synthesizing people's judgment, people's opinion based on their expertise levels and the answers that we provided to the survey. So we construct a matrix representing these people's level of expertise, and another set of matrix for representing the answers we gave to our survey, which is a pairwise comparison of indicators. These are the steps for implementing the AHP. And one important step is checking the consistency in the comparison matrix. That we need to make sure that the answers people provided are consistent. For example, if somebody said indicator A is important than indicator B and B is more important than C, but A is less important than C, then we regard that answer as inconsistent and we wouldn't be able to accept that. So we do the consistency checking, and then we found there are slightly inconsistency in people's answer, because in the survey we divided the importance scales into quite a few. So sometimes like humans' judgments are not that reliable, so it could mix things up. How we solved this was that we rescaled this, that we collapsed the original structure to a smaller, simpler structure. So to make sure that the answers we got are consistent. This is the definition for consistent ratio, which is the threshold for accepting the answers. And we accept answers with threshold less than 20%. And this is the example of the survey result from the water sector. We have got 25 responses in total, because the survey was sent out to WEF, the project participants only, and these people are expert in at least one of the three domains. So some people regard them as having little or a lot expertise, and some of them know nothing about water. And these are the consistency ratio calculated based on these people's answers. So the three different groups are people with different expertise levels. So the red one are no knowledge, and green ones are some knowledge, and blue are the people who consider themselves as experts. And the colored bars are the original consistency ratio calculated from the original scale. So we can see some of them exceeded the acceptance level, but after we rescaled it and recalculated it, we got the green bars, which are all below the threshold value, so we consider this to be ideal. And these are the weights derived using the AHP method and the data from the survey. So the left shows a table, the calculated value for the weights, and the right is a radar diagram showing these. And the black line represents those calculated from the original scale, and red dotted line are the modified calculation. So there are 7 indicators in the water sector, and this is the energy sector. Similar results. Weights for each indicators within the sector. And also similarly, we did this for food and energy. Food and house food. So then the problem is how we combine the availability index and the accessibility index. As we ask in the end of the survey, we ask a question of how which one people consider as more important, and the rough result we get was that people were saying these two things are equally important. So we gave equal weights for the rough availability index and the population access index. So therefore we merged the result and we collect the data for indicators listed in the table, and we did some standardization and then computed the reasoning metrics based on these indicators. And the problem we had was the data availability. So originally we thought we want to do a scale. We want to collect data from different regions and at small scales, which would allow us to make a spatial comparison and also across the time range. But then we realized most of the indicators listed here are only available as national average, and some of them has time series data, such as those in energy sector, so which is ideal for us to make a cross-year comparison. But there are also indicators such as those within the food sector. There are data, for example, like an average over 10 years. So we only have like a point data, for example, those around 1990 and those around 2010. So that gives us limited information about how this resilient index works. But that's the summary of this work.
Any questions?
Hi. Can you tell me how did you determine who was an expert?
Well, we asked the people to rank themselves. So the participants are all researchers in the WEF research program.
Okay.
So they are expert in either water, energy, food, or household.
So they're researchers in that area.
Yeah.
So expert in that sense. So certainly in food, household food insecurity, using experts by experience is considered to be very important to get a full picture.
Yeah. So we'll be able to prioritize people's answer, like is there improvement to give most weight and margin.
And how did you come up with this list of indicators?
This is some work done by a person whose name was Scott. He was previously a postdoc at Glasgow University. I think what he did was went through literature review and consulted experts in each domain and finally selected these.
And those weights you were talking about, they are for each sector, right?
Yeah.
But then do you also plan to combine across sectors?
Yeah. So this is a structure. We got the weights for the 4 different sectors,
Yeah.
and then we merged the first 3 as the web availability. And
Is there any weights for that?
so we
merging?
assumed equal weights,
Okay.
which is quite a bit simple and naive, but we currently don't have such a solution for.
So when you say equal weights, do you mean more or less you take a weighted average?
Yes.
Or you don't, I was wondering in the last step towards resilience, that perhaps resilience is more to do with an interaction of those two things rather than, so multiplying them rather than summing them. So it's only a problem if you have low resources and low household income, or at least that is that's more bad than you would expect by just adding the indicators together.
So you're saying like it's not capturing the interactions within the sectors. Is that correct?
I don't know. I don't know the evidence
Well,
in this area.
The fact was that it's difficult to quantify the interaction, and we don't even know how they interact. We kind of know how they interact with each other, but it's really difficult to quantify the interaction. So what we did as an exploratory study was simply summarizing the features within each sector and combine them, and we thought the weighted average is a reasonable way of like combining and merging them into one comprehensive text. But if you have any suggestions on capturing the interaction,
Okay, thank you very much.